2.5 Part 2. Alright, we're going to continue doing what we've been working on. This time we're going to work backwards. We're starting by working backwards. I'm giving you what the zeros are, and therefore you're going to come up with the equation. You're going to come up with the polynomial that was there. So keep in mind, in order to get a 0, it had to come from a factor, so minus 1, and then 2i. Something I want you to kind of star and mark in here is anytime you have an imaginary as a real, or as a 0, its conjugate is always there. So just because I tell you 2i, which means x minus 2i, if I tell you one imaginary, I'm also telling you the conjugate or the other one, 2 plus. So definitely mark that, star that, highlight that, because a lot of times you're only going to be told one imaginary because you need to know that one imaginary automatically is giving you a second imaginary. And the other part of that is it said it was a fourth degree. So if this is 1, 2, 3, there's got to be a fourth one that has to be put in somewhere. So at this point we get to distribute. So this is x squared plus 2x plus 1. This is going to be x squared plus 4. Distribute again. So we're going to get x4, 4x squared, 2x cubed, 8x, plus x squared plus 4. Combine our like terms, x4, 2x cubed, yes, please make sure you're putting them in the proper order, 5x squared, 8x, and 4, all equal to our f of x. So when you are asked to write an equation, please make sure you put f of x, because I'd hate to take a silly point off because you didn't write it in its complete form. But we did these a few sections back where we had a 0 and we wrote a polynomial. Same thing. It's just now we're going to be doing it with imaginaries, but it still has the exact same premise, that if you have a 0, you have its factors multiply together, combine like terms. A quadratic factor with no real zeros is said to be irreducible over the reals. Okay? What that means is that this one factors to imaginaries because it's not real, and this one does factor. It is reducible. It just factored to irrationals, not imaginaries. So if something is irreducible, it means its factors are imaginary. If it is reducible, then it means the factors are real. And sometimes real is just real ugly, like with square roots, instead of whole numbers. But square root of 2 is still a real number. I, not a real number. So irreducible over the reals, and I emphasize this because you're going to see it again, you're going to hear it again, you're going to see it on quizzes and tests. Irreducible over the reals means there are imaginary factors. Reducible means the factors are real. And that's the difference between those two things. Alright, page 4 of 2.5. We're going to factor the polynomial, and in this case we're going to be write it as a product of factors that are irreducible over the rationals. Okay? So what that means is that our factors can only be rationals. Our factors can only be rationals. So when I factor this, I'm going to get x squared, and what multiplies by 20 and subtracts to be 1, minus 5 and plus 4. That is done. Alright, because this is going to factor to an imaginary, which would be irreducible over the reals. And this is going to factor into square roots, and square roots are not rationals. Okay, so factors can only be rationals. All right, so let's look at the next piece. Linear factors. That means the highest power of x is 1. So up here, these are not linear. These are not acceptable factors down here in part B. Okay, so we're going to write linear factors and quadratic factors. Okay, so we now can have singles and we can have squares. Irreducible over the reals. Okay, so here we're going to get the linear factor of our reals, so we're going to get x minus the square root of 5, x plus the square root of 5, because that's how we're going to get 5 in there. And then our x squared plus 4. So put it into our completely, I'm sorry, that's backwards, irreducible, and quadratic factors are irreducible over the, here's our linear factors, there's those, and the quadratic is irreducible over the reals. So here's our quadratic, and it's the reals. So our linear factors are good, and the quadratic is over the reals. So here's our quadratic, and it's still real. I need to continue going. Those are linear, those are done. And now we get to do this imaginary part, x plus 2i and x minus 2i. The wording on this is a little shady. So if you had done the 2i minus 2i part first and left the x squared minus 5, that would be okay, because I can see how you might read this as the irreducible over the reals as being the imaginary part. So if you did, that's fine. But just know that all pieces, in the end, all pieces factor down. Alright, last example here. Find all the zeros of this polynomial given that 1 plus 3i is a 0. Well, back to what we said on the last section, part 1 there. If I know 1 plus 3i is a 0, then I also know its conjugate is a 0. I know I'm going to have 4 zeros. Okay. Because I know 1 plus 3i and 1 minus 3i are zeros, what I need to do is I need to be able to find the rest of them. The problem is 60. Now we could list out the factors 1, 2, 3, 4, 5, 6. Are you getting my drift that there's going to be a lot of them all over 1? Or because this would probably be a non-calculator question, we need to find what this factor allows it to be. So 1 plus 3i is a factor, and 1 minus 3i is the other factor. And when I distribute, and again, distribute here, I'm going to end up getting x squared minus 2x plus 10. And you get that from doing all this distributing, combining of like terms. Because this is a factor, I know that I can divide longhand, unfortunately. I know it is going to go in evenly, though, because it is a factor. It will go in evenly into my original polynomial. Only look at the first term. So x squared, x4 minus 2x3, 10x squared. Switch the signs, goes away. So we're going to get negative x cubed minus 4x squared, and the rest of this is going to come down. X squared into negative gives me negative x plus 2x minus 10. Switch our signs, so the first one goes away. And x squared into negative 6x squared is negative 6. And then it all becomes 0. So it went in evenly, x squared minus x minus 6. Well, x squared minus x minus 6 factors nicely, so that our x is 3 and negative 2. So find all the zeros. Well, 2 of them were given to us. And the other 2 we found. Okay, so sometimes, especially with this one, it's easier to go back and do long division, even though we may not like it. This is probably a non-calculator question, therefore you need to understand that you may not have your picture of your graph to go back to and check. And if I list out all the possible zeros, that's a whole lot of zeros to, check and test synthetically. So by putting this back into polynomial form, I can divide it in and find the other missing polynomial, which was very easy to factor to find the real pieces. And there's my 4 zeros, 2 real, 2 imaginary. And that is the second part of 2.5.